In this segment, I'm going to present the solutions to your binary to decimal and your decimal to binary conversions. When you opened up the file that was called O2 binary, you should have had a file that looks just like this and printed it out. You have plenty of space to write in. I'm going to go here and show you my solution file. Let's take a look at our binary to decimal conversions. Here's our first binary number, 111000011. What we need to do is to use our chart here and say the first item, 1, is equivalent to 128. So I'll take 128, put it over here, plus this next item here is a 1 here. That means 64, so I bring the 64 over, plus the third item here is 32. I bring that over here, plus here's a 0, so I do not take the value from there. There's a 0, I do not take a value from there, and another 0, and I do not take the value from there as well. And that's where our 3 zeros come in. I have an item here. This is at this location, so it's a 2 that I bring down. This item here is in this location, so its value is 1, so I bring the 1 down. If I add these numbers up, it gives me the decimal number of 227. The next item here, I've got the first 2 zeros. That means I do not take a value for these two, so I have 2 zeros here. This item here is 32. I bring that over. This item, worth 16. I bring that over. This item is 8. I bring that over. Now I have some zeros here. I don't bring anything over for that. I don't bring anything over for that. And then 1, and I bring 1 over. I add these numbers up, and they equal 57. To work through the next one, the first 3 items are zeros. The next item, I'm going to bring a 16 down, an 8 down, and then a 4 down. Then I'm not going to bring anything for the last 2. That's going to give us 3 zeros plus 16 plus 8 plus 4 plus 2 zeros. This equals 28. We work our way down here. The next one, we have 128 plus 64 plus 32. I don't add my 16 in. I don't add my 8 in. I don't add my 4 in. But I will add my 2, and I won't add my 1 value. You can see why memorizing these numbers up here can make it very easy for you to make these conversions back and forth. And if you do plan on going for any testing, whether it's Cisco testing, Microsoft testing, whatever that's related to TCP IP, be prepared to make these conversions. They're very important. So we add our numbers up, and we get our totals. And you can see the other solutions. And hopefully your solutions look very similar to this. Let's go down now and take a look at the conversion from decimal to binary. I've got the binary value chart up here. And what I did for the solutions, I popped the binary value chart in between each so we can follow along with what we're doing. If you're given the decimal number of 10 and you need to convert it from decimal to binary, we look at our values here and we say, what is the highest number in here that we can subtract from 10? We work our way up and we realize it's 8. 10 minus 8 leaves us 2. We take our 2 and we see what's the highest number in here we can subtract from 2, and it's 2. That gives us 0. For each item that we subtract, we should mark it. And if this is your paper, what would be very easy to work with is, as you're going through here, put a little mark here. So I put a mark here by 8 and a mark here by 2. And that will let you know that you're going to have zeros. You're going to have a mark by 8 and a mark by 2. And this is your binary equivalent of this decimal number. Let's go to the next one. Here's our values. But at this point, hopefully the memorization is starting to be in your head a little bit. We take 54. Highest number we can subtract is 32. So you might want to take a little mark, put a mark there. That gives us 22 left over. And we take 22. We minus 16. It's the highest value we can subtract from 22. It gives us 6 left over. We have 6. The highest number we can subtract from 6 is 4. So we take 6 minus 4. It gives us 2. 2. The highest number we can subtract from 2 is 2. It gives us 0. So we had gone through and marked our 32, and then our 16, and then our 4, and then our 2. We'd have a binary number that looked like this. Next one, 227. Highest number you can subtract from 227 is going to be 128. So put a little mark right here. Then we have 99 left over. Highest number you can subtract from 99 is 64. Put a mark right there and subtract. Next item, we have 35 left over. We can subtract 32 from it. Put a mark there and subtract 32. It gives us 3. Well, we can't subtract that from 3. We can't subtract that from 3. We can't subtract that from 3. That gives us our 3 zeros here. But we can subtract that from 3. And that gives us a leftover of 1. 1 minus 1 is 0. So we could see we would have subtracted a 28, or 128, a 64, a 32, skipped over these 3, and then subtracted a 2 and a 1. And that gives us our binary equivalent number here. Next one, 37. Highest we can subtract from here is 32. That gives us a remainder of 5. We can't subtract that from 5. We can't subtract that from 5, but we can subtract that. 4 minus 5 gives us 1. We can't subtract 2 from 1, but we can subtract 1 from 1. So the numbers that we subtracted from it, 32, 4, and 1. The places we translate down to here. We got a 0 for the 128 spot, a 0 for the 64 spot. We have a 1 for 32. We have the 0 for the 16 spot, a 0 for the 8 spot, because we didn't subtract those. But we did subtract something from the 4 spot. We didn't subtract anything from the 2 spot, but we subtracted something from the 1 spot. Let's work our way over here. We can see our 55. So we can subtract 32. That gives us 23 left over. We can subtract 16 from that. That gives us 7 left over. 7, we can't subtract 8, so we skip over that. That's where this 0 comes in there, because that's the 8 value, but we didn't use it, so it's a 0. We can subtract 4. That gives us 3 left over. We can subtract 2 from our 3. That gives us 1. And we can subtract 1 from that. There's our binary conversions from the numbers that we actually subtracted. Then 47. We can subtract 32. We can subtract 8. We can subtract 4, 2, then 1. And all the numbers that we use to subtract, we bring them down here. And then 52, we can subtract 32. That gives us a remainder of 20. 20 minus 16 gives us 4. 4 minus 4 equals 0. Hopefully your solutions look very close to the solutions that I have up here. And as you can see, it's just a little bit of thinking and just a little bit of memorization. We're only talking about memorizing these items here. The binary to decimal and decimal to binary conversion should be rather easy for you.